The container widget is one of the most basic yet powerful widgets in Flutter because it allows you to do a lot of stuff with minimal lines of code. The docs say that it is a convenience widget that combines painting, positioning, and sizing widgets. To see this in action, let's remove the existing container widget and replace it with a text widget inside the body of our scaffold. Let's now wrap this text widget with a container widget using the shortcuts menu. We observe that the text widget added as the child of the container widget uses the child parameter. This child parameter can be found in a lot of other widgets as well and is mostly used to denote that this widget is being wrapped by another widget. On hot reloading, we see no visible changes on the emulator. One of the most common use cases for a container widget is the ability to add a background color to something using the color parameter. Next, let's set custom dimensions for a container using the height and width parameters. We can see that our text touches the top and left edges of the container. To add some spacing between the container's edges and the text widget's edges, we can make use of the padding parameter. The padding parameter takes in a value of type edgeInsetGeometry, which is an abstract constructor that enables subclasses to provide const constructors so that they can be used in const expressions. EdgeInsets is another class that extends edgeInsetGeometry and allows us to specify the offset from all four sides. It is a good practice to declare these EdgeInsets as const instead of new. We'll learn more about const in another lesson. To add an equal amount of padding to all four edges of the container, we can use the all-named constructor of the EdgeInsets class. Now, on hot reloading, we see that the container adds a spacing of 12 logical pixels inside it. Similarly, to add some spacing between the container and anything surrounding it, we can use the margin parameter. The margin parameter also needs a value of type EdgeInsetsGeometry, just like the padding parameter. Let's make this twice the size of the padding so that we can easily understand the difference between padding, which is the space between the container and its child, and margin, which is the space between the container and its parent. To align the content inside the container, we can use the alignment parameter, which is quite straightforward to use and offers predefined alignment values. Let's align the content in the center of the container initially and play around to see a couple of different options. Instead of using the height and width parameters, we can get a lot more control by using the constraints parameter if required. Let's use the expand name constructor from the box constraints class for now as its value and see how it is handled within. In its definition, we see that if we do not provide a height or width to this expand constructor, it uses infinity as its value and hence expands to the maximum size available, which is what happens in our case. Note that this height and width are not to be confused with the height and width that we provided for our container. These height and width here are the parameters provided to the expand constructor and not the container. There are a few other named constructors such as tight, tight for, and loose that can be used as needed. Next, to see what holds preference between height, width, and constraints, let's see the implementation of the container widget. In the container widget, we see that the constraints parameter checks if either of the width and height values provided to the container are non-null. If yes, then it checks if the constraints value provided is non-null, which is exactly what our case is. The title method then ends up creating a box constraints instance after this. It's better to visualize this using code, so let's add a height attribute to our expand named constructor. In this case, this is the same as using height on the container widget. Hence, we can remove the height parameter. Plus, let's remove the width as well. Because of the dimensions provided to the expand constructor, we now see that the height is constrained to 300 logical pixels, but the width expands to cover all the space available. To add borders and curved corners to our container, we can make use of the decoration parameter. Let's add a color to this box decoration. Doing so results in a failed assertion because the container can only take in a value for color or for decoration. We can see the exact statement which results in this error. This assert statement inside the constructor mentions that the color parameter in the container's constructor is just shorthand for the decoration parameter. So when we specify both color and decoration, the container fails to understand which one to use. Hence, we need to remove either color or decoration. In this case, once we remove the color parameter from the container and hot reload, we see that the new color is picked from the one specified inside decoration, and everything works as expected. To make the container have a border, we can use the border attribute and specify a value using the all named constructor of the border class. This all constructor is similar to the one we used with edge insets for padding and margin. It prepares a border in all four directions. We can further add a color to it. For rounded corners, we can specify a border radius and provide the value for the radius in the circular constructor of the border radius class. Note that circular, all, and expand are all named constructors, and these type of constructors are quite common in Dart as they offer much better readability. Let's finally center our container widget in the center of the scaffold's body by wrapping it with a center widget. This brings us to the end of talking about the container widget. Note that this center widget centers the container inside the scaffold, but not the content inside it, even though it looks like it does. To further clarify this, let's add some more text to the text widget inside the container widget. We now see that this long text was never centered. However, the text widget inside the container widget was physically in the center of the container because of the alignment value we provided earlier. To center this text, we need to use the text align property of the text widget. So to sum up, the center widget centers the container inside the scaffold. The alignment is centering the text widget inside the container widget, and the text align value is centering the text inside the text widget. Also, it may look like the text widget is taking up the entire container, but that's not true. It is only occupying the space that is needed by the text inside it. This can be made clear by wrapping just the text with a container of a different background color.